Welcome to my class. In this lecture, I will go over more complicated arithmetic sequence. Okay. The question is given. What is the sum of 35 terms of the following sequence? You have here 1, 2, 4, 9, 1936. Okay, whenever we have a sequence problem, we have to check the increment. Okay, so we just write over here 1, 2, 4, 9, 10. Increase by 1, increase by 2 here, increase by 5 here, increase by 10 here. So this is not fixed value. Then we have to analyze one more step. So let's call this one is a subsequence 1. Then 1, 2, 5, 10. And then here, increase by 1, increase by 3, increase by 5. 1, 3, 5, also not fixed value. So let's say this one is the second subsequence. Now, we write down here and check. Increase by 2, increase by 2, increase by 2. Now we have a fixed value increment. So let's say this one is the original sequence, and this one is a subsequence, and this one is a second subsequent. Okay? Keep in mind this one. So we try at the general term of second subsequent. Okay, the first term is 1 and difference is 2. It was a fixed value. So we can write general term as first value plus difference times one lesser term and minus 1. If you expand and simplify, we will get 2n minus 1. Once we have a general term, you just need sigma notation to get the sum. So let's say as a subsequence, n is the sum of a second subsequence. Okay, we have a general term. Whenever we have a general term, you just put the sigma notation, then we can get sum. Now, once you put it, you use a distribution property, then this one come out 2 times sigma k minus sigma 1. But note here, okay, here we don't have a k. If we don't have a k, we just multiply these two values. Okay? So, we remember formula for sigma k. Sigma k is n times n plus 1 divided by 2. So this part we replace. This is just a symbol. When you have a symbol, nothing to do. So we have to replace by real expression. So 2 times sigma k, which is n times n plus 1 divided by 2, and minus n. If you don't have a k, you just multiply. After you cancel 2 and 2 and expand and simplify, and you have here n squared plus n, but plus n and minus n cancel. Eventually you have n squared only. This one is the sum of a second subsequence. Then we can get general term of first subsequent. So Bn. First value plus the sum of increments of one, of course, or less term. So first value was 1, and then sum of increment was n squared, but one lesser term. That's why in place of n, we replace n minus 1 squared. So we expand and simplify, then it comes out n squared minus 2n plus 1. You expand this one, you got it, right? N squared minus 2n plus 1. Well, you have one more, so it will come out n squared minus 2n plus 2. So this one is a general term. Once you have a general term, we can get sum by adding sigma notation, as we see here. So sum of the first subsequence will be sigma general term. Okay? General term. So sigma k squared minus 2 times sigma k plus 2n. If you don't have any k, you just multiply. Okay, we derived the formula for sigma k squared last previous lectures, and this one we already have. So we replace the formula for sigma k squared was n times n plus 1 times 2n plus 1 divided by 6, and the minus 2 times this one, n plus 1 times n over 2, and the plus 2n. After you expand and simplify, expand and simplify all of them, then eventually come out here. Okay, if you think I'm going too fast, over here you stop your video and then work out this one yourself on different paper. Okay, it will come out like that. Okay, this one is a sum of forced subsequence. Once we have a sum of increment, this one will be an increment of forced primary sequence. So forced value plus a sum of increment. Okay, this one. But one last term, don't forget that. So 1, A1 is 1 plus, okay, in place of n, you replace k minus 1. In place of n, you replace k minus 1. In place of n, you replace k minus 1. One lesser term. You expand all of this one and simplify and add 1. Okay? Then it will come out 2n cubed minus 3n squared plus 19n minus 6 over 6. This one is a general term. Okay? After you expand, again, here, you better stop video and you work out on paper yourself to check it. If this one actually come out, this one or not. Okay, of course, like a time consuming. That's why I'm not going to work one by one. Then it will take it too long. Okay, but you can stop your video and you work out and you can compare. Now, once we have a general term, we just put sigma notation here, then we can get sum of sequence. So sum of a primary sequence, you just put sigma notation in general term. Okay, just before we had it. Okay, and then you expand 2 and 6 reduced to 1 over 3 sigma k cubed minus 9 over 6 will be 3 over 2. 3 over 2 sigma k squared and 19 over 6. Just state this. No common factor, so you cannot reduce. So 19 over 6 sigma k minus 6 and 6 cancel, so you have only 1. So 1n. Now you replace this formula, and this formula. This is just a symbolic expression. Just a symbolic expression don't give you anything. Okay? So you have to replace by actual formula and simplify. Okay, to save time, I just let you know. Okay, what was the formula for sigma k cubed? It was quantity n times n plus 1 divided by 2 quantity square. And the sigma k square was what? N times n plus 1 times 2n plus 1 divided by 6. And the sigma k was n times n plus 1 divided by 2. Okay? You just replace and simplify. Then, after long trip of working on paper, you will get this one. Okay? But when you have this kind of long step work here, then you better make sure actually come out or not with the first few terms. Okay? So with that, let's replace n by whatever number, pretty much like kind of at the beginning values. Okay? You remember n times of quantity 1, 4, 11, 4. 1, 4, 11, 4 with lower and lower power, okay? Denominator with 12. Okay, we try to get sum of the first 4 terms. Then 1, 2, 4, 9 give you 16. Okay, 1, 9, 10, and 26, 2 and 4 will be 16. Now you replace n by 4 to get the value. 4 cubed minus 4 times 4 squared plus 11 times 4 plus 4 and divided by 12. Okay? We just replace the value of n by 4 here in the formula. Okay? The formula was here. Okay? Once we have that, you just calculate now. Using calculator, you come out 16. So, true. Okay? Once we checked, we go back to original questions. The original question was a sum of 35 terms. Here is the one. I have one more check, okay? With n equal 5. 1, 2, 4, 9, 19 make 35. And then you replace the value of n by 5. 5 times quantity. 5 cubed minus 4 times 5 squared plus 11 times 5 plus 4. Exactly the same thing, but we just replace value n by 5 instead of 4, right? Then divided by 2, eventually calculation give you 35. And we check with the 2 cases, then pretty much reliable. Okay? Pretty much reliable. Then you go back original question. The original question was a sum of 35 terms. Means we replace n by 35. 35 times the quantity, 35 cubed, minus 4 times 35 squared, plus 11 times 35 plus 4, quantity n over 12. It will come out 111,895. Okay? 905. Okay, you understand, right? Now, okay, one more time, I emphasize, you better memorize sigma k squared, n times n plus 1 times 2n plus 1 divided by 6. And the sigma k cubed was n times n plus 1 over 2 whole quantity u squared. Okay, we examined with one example. If you want to practice more, you go to my website, www.durkkim.com, practice test, Algebra 2 series PDF. And you have a bunch of more similar problems. Okay? Okay, thank you for your watching. See you next time. Bye.